Hi, in this video I'm gonna go over the unit circle. Okay, so unit circle, not really special, but it is a very powerful and very useful circle. Okay, so here, as you can see on the screen, we have a circle on the x and y coordinate, and the reason why we call this circle a unit circle, because the radius unit circle, they all have a radius of 1 unit. Okay, the radius of 1 unit. So if I measure, this is my center, and my center to my circumference, if I measure that, that's gonna give me 1 unit. If I measure the distance from this point to my circumference, again, that is gonna be 1 unit. Okay, now that's why we call them unit circles, because they all have a radius of 1 unit. Okay, so let's say today, what is this point gonna be? These 4 points that I have right now. What's the coordinate gonna be? So here, that will be 1, 0, right? Because I'm going 1 unit in the x direction, and then I'm not going up or down. At this point, that will be 0, 1. Oh, I mean, this is 0, 1. This point, that will be negative 1, 0, right? Because we're going the negative x direction. Here, that will be in negative y direction. So 0, negative 1. Okay, so these are the coordinates for my x and y intercepts, kind of. All right? Now, what if I say I want to find the coordinate of this point, let's say point P. The coordinate of point P. Okay, so how do I find that? In order for me to do that, I'm going to involve my trig, which are sine, cosine, and tangent. These are the three trig functions that we have came across. So I hope you guys still remember this. So for sine, it is my opposite over my hypotenuse. My cosine, it is my adjacent over hypotenuse. For tangent, it is my opposite over my adjacent. Now, be careful, please be careful. We can only apply sine, cosine, tangent to triangles that look like this. Not just look like that, you must have a right triangle. Okay, so let's say if the angle I'm trying to find here is here, so the angle here, so sine theta. So for this angle, my opposite side is here, my adjacent side is there, and my hypotenuse will be there, right? The hypotenuse is always kind of across from your right angle side, right? So the hypotenuse is always the longest side, or you can think of it as the side that is opposite from the right angle side. Okay, so for sine theta, my sine theta would be my O over here over my H. Okay, my cosine theta is gonna be A over H. My tangent theta is equal to my O over A. Alright? Now, if I change the angle, let's say if I go with another angle, instead of theta, I'm going to choose this part. I'm going to call that angle beta. Right? So sine beta, for my angle beta, where's my opposite side? My opposite side is here. Right? This is my opposite side. So since I'm changing the angle, my opposite side, my adjacent side will also be different. Sine beta would be this part. That's my O, right? I'm gonna say this is O beta, right? This is O beta over, now in this case, my angle is here, so this is my A. This is my A beta, right? So, and hypotenuse will always stay the same, because hypotenuse, again, is right opposite of your right triangle side. So for my sine beta, it will be just my O beta, right, this length here, over hypotenuse, my cosine beta would be my A beta, which my adjacent side for my angle beta over hypotenuse, and tangent of angle beta would be my opposite side of beta and over the adjacent of beta. Okay, there was one property where we also came across a long time ago. My sine beta would also be equal to my tangent beta is also equal to my sine beta over my cos beta. Right. So in other words, my tangent theta here, tangent theta is also equal to my sine theta over my cosine theta. Okay? Now, anyways, these are just review, right? These are just sort of very basic review on the stuff that we learned long time ago about tricks. Now, how do we apply all this to a unit circle? How do we apply all of this to a unit circle? Now, again, the reason why I sort of review on this simple trick stuff is to find that point P. So, what I'm going to do here is I'm going to make this right triangle there. See that? So let me zoom in. So I have this part, right? And it's a right triangle, which means I can use my sine, cosine, and tangent, or some of you guys call it SOHCAHTOA, right? SOHCAHTOA, right? Now my angle is going to be here, right? This is my angle, so I'm going to call it theta. So this is my angle theta. All right, and the P is here. This is my point P. Now, my x over here. So let me replace the question mark with x. Let's say this is my x, this is my y. Then this will be my x, and this part will be my y. Correct? So this is my x. This is my y. So if this is this is y, then this is y as well, right? So I'm going to put the y there. Okay? Now, let me ask you, what is the length of the hypotenuse here? What is the length of this? I hope your answer is 1, right? Because this part is the radius of my unit circle. So, and I call it the unit circle because it has a radius of 1 unit. Right? So that's 1. So now let me combine the big triangle I have here with my SOHCAHTOA. I'm going to say sine of theta is equal to, so sine of theta is equal to my opposite side, which is my y, over 1. My cosine theta, sorry, let me finish that before I get to cosine theta, which is just equal to my y, correct? My cosine theta is equal to adjacent is my x, so my x over my hypotenuse, which is 1, so cosine theta is equal to x. My tangent theta is equal to simply sine over x, so sine theta over tangent theta. We already mentioned about it just now, right? Over here. So which is just equal to y over x. Okay, now let me ask you guys. Here, I already said x is equal to cosine theta. Y is equal to sine theta. So, what would my x and y value be? So, instead of x and y, I can now erase that and replace them with what I just found. So, my x is equal to cosine theta, and my y is equal to my sine theta. Got that? Got that? Okay. What about tangent? Doesn't really do much for now, but if you think about it, this will give us the slope, right? That is the slope of this line right there, given the angle, of course. Make sense? But for now, what you guys do have to know is your x coordinate your x coordinate, let's say given the angle, the x coordinate is just the cosine of that angle. Given an angle, the y coordinate is sine of that angle. Okay? I'll show you guys an example. All right. Okay, so here I'm going to show you guys an example. Now, I have a unit circle here, and let's say today I have this angle, right? Let's say this angle is, say, 45 degrees. All right, 45 degrees. Oop. Okay, now, they want us to find and the point there, let's call it B. They want us to find the coordinates of point B. I find the coordinates of point B. Now, if you guys took the notes from what we just talked about in the first 10 minutes of this video, we know that the x coordinate is just the cosine of the theta, and the y coordinate is sine of the angle, the theta. Now, if I want to find my point B, the x coordinate would be cosine of 45 degrees, and your y coordinate would be sine of 45 degrees. And if you put that in your calculator, you will get root 2 over 2, root 2 over 2. Okay? Now, again, this is a unit circle, right? So which means the triangle that I have here is, okay, so if this is one unit, if this is 1 unit, then the triangle that I have here, this is 1, right? And this is right triangle, right? I kind of have this arbitrary height there. And right now I found my x is root 2 over 2, my height is also root 2 over 2. So if I apply Pythagoras theorem, I should have root 2 over 2 squared plus root 2 over 2 squared. And let's see if that gives us 1. But by theory, it should, right? So let's find out. So this is 2 over 4 plus 2 over 4, which is 4 over 4, which is 1. So there you go, right? So that makes sense because we established this cosine and sine for my x and y coordinates based on the fact that this is 1 unit. Okay, anyways, let's look at another example. So I'm going to use a different color. Let's use red. If I have an angle here, let's say, so this angle is going to be obtuse. I hope you guys still remember what's obtuse angle. That angle, say for example, maybe 140 degrees or 140 degrees. Now, I want to find, let's say this is point C. This is point C. So for my point C, same thing. My x coordinate would be, actually, you know what? Let me change the angle. I'll change the angle to somewhere, let's say here. The angle is all the way there. Okay? And I'm going to change the angle to 135 degrees. 135 degrees. Okay? So I'm gonna have this angle 135 degrees. So my theta is here. This is my theta. My theta is equal to 135 degrees, and at point C there, I want to find the coordinates of point C. So same thing, right? Same thing. I'm just gonna say cosine of 135, and that will be my x coordinate. My y coordinate will be sine of 135. Now, for those of you guys who are using a calculator right now, you should not be using it. Why? Because if this whole thing is 135, how much is this? This would be 45, yes? So, which means I have the exact same height, which means my y will be the same. this y over here is the same as that, right? What about my x? So my y is, I don't even have to use my calculator, right? I know that this is 45, that's 45, so the y should be exactly the same. What about my x? What about my x? Again, I'm going to use my x that I have from point B. I'm going to use that, but since my point B is going towards the positive x direction, okay, so this is my x, this part is my x. Now if I'm going this direction, what's that going to be? That would be negative x, right? That would be negative x. So I know that my x coordinate will be negative of root 2 over 2. And that's it. If you don't believe me, go ahead, put it down in your calculator, and you'll see that. All right. Okay, I think this is. I hope you guys understand this sort of. It is almost like a reflection, right? Almost. Let me ask you, what about this? Try to find if my theta is equal to say 225. 225 degrees. I'll give you a hint. This is 180 plus 45 degrees. This is 180 plus 45 degrees, so I'm talking about somewhere here. Now, what is, and let's say this point is D. What do you think? Without using a calculator, let's try not to use a calculator. What is the x and y coordinates gonna be for your point D? Think about it, and I'll see you guys in class. Bye bye.